Greetings and welcome to Particle Physics. My name is Stephen Pollack. I'm a professor of theoretical nuclear and particle physics at the University of Colorado in Boulder. Those words may or may not mean a whole lot to you right now. Theoretical nuclear and particle physics. It's a branch of physics, and by the end of this course you're going to have a very good sense of what those words mean and what it is that I study and that we're going to be learning about in this course. Particle physics. It's a branch of physics. Physics as a whole is just the study of what the world is made of, how things work, how they behave, why they behave that way. It's trying to understand things and phenomena, both natural and technological. In the ordinary world, you toss a ball up in the air and it follows an arc, and we can understand that path. It makes sense. It follows certain laws of physics. Particle physics is a branch of this study where we really try to get down to the bare bones. What is the world made of at the smallest level? What are the simplest building blocks and the most fundamental rules and ideas which govern how things work, why they behave the way they do? Particle physics is about the particles that make up the world that we live in. I could describe particle physics in 5 words. Those 5 words are somewhat technical. They're defined by physicists to have very definite meaning, but they also connect with our everyday intuitions and uses of those words. Force and energy, matter, space and time. Those are the 5 building blocks of the field of particle physics, and in fact of much of physics itself. Force and energy refer to how and why things interact. Matter, what are the things? What is the world made of? Space and time, what is the framework in which all of that stuff is going on? These are the concepts of particle physics, and as we go on in this course we will be dealing especially with the middle, the matter, and also with all of the other elements, the forces that matter feels, the energy that is involved in these interactions, the space and time in which they live. Look around you for a moment. Think about the world that you are in right now, the physical world, the objects and the phenomenon. There are hard things wherever you might be that are so hard you could try to break or bend them and you couldn't. There are also soft things like your hands or your skin. There's ethereal stuff like the air that you live in that you can just barely detect or sense. And then there's the things going on in that world, the sound that's hitting your ears and the light that's striking your eyes, the colors, the textures. All of that stuff is the realm of physics. And you could imagine that this enormous diversity of phenomena is overwhelmingly complicated. I mean, you can have this sense of the world as being filled with a whole bunch of different things, and we could study any one of them. That might be a branch of science, and it's hard to imagine that you can tie it all together. But we can. This is one of the wonderful things that we have learned about the world, is that everything physical, from objects in this room, objects in outer space, objects in the deepest galaxies, and everything in between, all arises from a very simple set of rules and a very simple set of ideas and fundamental building blocks. So that's where we're going in this course. What are those ideas? What are those building blocks? How can we make sense of them? Let's go back 2,500 years. This is an old question. People have been puzzling about what the world is made of from time immemorial, and I guess they didn't write it down in the days of cave people, but we do have records of Greek philosophers thinking about this. What is the world made of? We're going to be learning in future lectures about some of these folks and their ideas, but let me summarize sort of 2 viewpoints that arose 2,500 years ago. There was Democritus, a Greek philosopher from about 400 BC, who had this idea. He wasn't the originator of the idea. He was following in a long tradition of other philosophers who were thinking about how the world works. And his idea was that everything is made of little chunks. He called them atomos, which means unbreakable or uncuttable. Let me give you a kind of a concrete metaphor to think about Democritus' idea in real terms. Let me hand you a stick of butter. Okay, this butter is an object, it's a physical object, and it has certain characteristics. is yellow, and it's soft, and it melts if you heat it up, and it has a certain heft to it. You can describe it, you can study it and understand it. It's a material object. Now what if I chop it in half and throw away half, and you're left behind with a half a stick of butter? I think we would all agree there's still butter there. It's less massive, but it's still definitely butter. We haven't changed the essence or character of this material. So if you want to understand butter, it doesn't matter how much I give you. So what if I chop it in half again, and again, and again? So now you've got a pat of butter. It's still butter. There is no difference between the pat of butter and the original stick except for how much I gave you. And now Democritus is imagining, what if I keep cutting it in half and in half and in half again and again? Ultimately, believes Democritus 2,500 years ago, we will come down to a chunk, an individual, indivisible, uncuttable chunk of butter. It's physical, it's real, it's a little thing that you could imagine seeing or looking at, although it turns out that it's much smaller than anything you could actually see with your eyes. And this is Democritus's idea of atoms. They live in the void. They move around, they interact with one another, they're real, solid, physical objects. Okay, that's an idea. It's a philosopher's idea. And there were other philosophers at that time who disagreed completely. In fact, Aristotle, probably one of the most famous philosophers of that era, disagreed a lot, and in fact most of what we know about Democritus's ideas come from Aristotle's critiques. Aristotle had an idea which by modern standards is a little more nebulous. He believed the world is made of earth, air, water, and fire, but they're not physical chunks. They're more like characters or qualities. And so matter is infinitely divisible. You can keep cutting that butter into smaller and smaller and smaller bits forever. It's butter all the way. Aristotle's ideas survived for thousands of years. He was a very brilliant man in many respects, had a lot of influence in the fields of religion and religious philosophy and philosophy in general. Many of his scientific ideas, this one in particular, are really quite discredited now. There is no evidence of what Aristotle had to say, and there is a lot of evidence for what Democritus believed. But neither of those fellows was a scientist in any modern sense of that word. They believed that you can understand the world just by thinking about it. Just be a philosopher. Ask yourself, how should the world be for it to make sense? That turns out to be a very unproductive way of understanding how things work. It's much better to go into the laboratory and ask nature, how are things? Not what do we believe is the way it should be, but just take data, collect information, and ask yourself, how does butter behave? And you can discover, it took over 2,000 years, it was in the 1800s that people began to come up with concrete evidence that indeed butter is composed of what we would now call molecules. And then at a later time, we discovered that those molecules themselves are understood to be built up out of even smaller objects, which we now call atoms, after Democritus's original idea. So this puzzle about how the world works has been around for a long time, and it remained unsolved for a long time, and I would argue that it has been solved today. I know that sounds a little bit like an arrogant physicist's statement that we understand the world, and I'm going to put lots of asterisks on it, and as the course goes on, we're going to really be talking about what we do know and what we still don't know. What are the remaining puzzles, and what are the deep questions that we have not yet resolved. But to a very large extent, we do know that the world is made of atoms. We have direct physical evidence. We have electron microscopes that can image individual atoms now, and even subatomic particles. The atoms are themselves made of smaller constituents. The true building blocks of nature are smaller than atoms. That's a fairly recent idea, and one which we're going to be visiting over and over again in this course. And even those subatomic particles, we have direct evidence. They leave little trails behind them in particle detectors, kind of like the trail you see when you look at a jet airplane. Even if you can't see the jet, you can see direct evidence of its passing. And